Yes, good evening, friends. Welcome to the session once again. I hope my audio and video is working fine. Yes, good evening, friends, once again. Today we are going to start a new chapter, and that is biogeography. Okay, today we are going to start a new chapter, that is biogeography. Under biogeography, we will deal with the soil, also the plants and animal distribution. Okay, now means the natural vegetation regions. Clear? As I told you yesterday, there we left behind some important section under our oceanography. But as per the schedule, we'll have to continue. Therefore, today I am starting a new chapter, that is biogeography. So today the point of discussion is biogeography part 1. But don't worry, after we finish this session, I will take up the oceanography section part 9, 10 and 11. Okay, that which I will schedule later. Okay, later or next month. Later of this month or next month. Clear? But before we go into the session, as we wait for some more learners to join in, let me just give you some information from the Unacademy platform. Because of the popular demand, the Resolve 2022 availing for 22% discount. Okay, actually it was 3rd of January, extended up to 5th. So you only have some few hours left before midnight. Therefore, you kindly go and avail this 22% off. You can use my code, that is SUNEP10. It is for subscription type of plus combo and iconic combo, either for 1 year, 2 year or 3 year. If you are going for a 3-year subscription of this iconic combo, you are getting a discount of around 34,000, which is a huge amount of money. Okay, so don't wait. If you haven't subscribed, kindly do so. You only have some few hours left. Clear? Chalo. Your prelims is right very near, that is in the month of June. Your 2022 prelims is in the month of June. Taking this into consideration, in Unacademy platform we have this comprehensive batch course on GS. It is started today, that is 5th January. Also, in your roadmap, suppose if you are planning to sit for 2023, then you can still go for Expedition 2023 or Mission 2023 or Lakshya 2023. One of the best thing about this course is, if you are going for a 1 year and above subscription, you are getting 20 GS book. Now this 20 GS book is specially curated for your GS section. Once you can get hold of this book, you don't have to go and search for any topic under your GS in any other sources, thereby saving many of your precious time. And also at the same time, this 20 GS book has been designed in such a way aligning to the recent trend in the UPSC type of the question that has been asked in the UPSC exam. So it is latest, updated and to the point. Each and every topic and subtopic in your syllabus under your GS is covered under this 20 GS book. Okay, so you kindly utilize such an opportunity. Nothing like practicing for your prelims as well as revising for what you have studied through this MCQ. In Unacademy platform, every Sunday we have this UPSC Compact. That is this coming Sunday, that is 9th of January at 11 AM, 56 questions, 60 minutes. You will get a scholarship from a pool of 4 crores plus rupees. The scholarship is, if you rank, percentage of the scholarship is 100%. If you rank between 1 to 3, it will continue 75%, 50%. Even if you are within 500, top 500, you end up getting scholarship 25%. Okay, you lose nothing, you only win. Okay, you see here, let me tell you once again, for the benefit of all, UPSC or any competitive exam for that matter is not a university, college or a school exam. It is a competitive exam. What does that mean? You don't have a pass mark. It is a merit-based selection depending on the vacancies. Therefore, by attending such a UPSC Compact, you will come to know at what level of preparation you are. Thereby, you will get an opportunity to self-assess yourself. Just by sitting yourself in one room, reading day in and day out, you won't be able to get an opportunity for self-assessment. Therefore, you lose nothing, you only gain. You can use my code as your enrollment code, that is SUNEP10. Okay. With that basic introduction, let us continue our discussion of today. Okay. Biogeography part 1. Okay. Under this biogeography, we are going to discuss soil, and also we will be discussing plant and animal distribution. But first, today we will begin with our discussion of soil. You see here, soil is a very important, soil plays a very important role in human civilization and also for the natural vegetation which is surrounding us. Now, how this soil has been formed? During the initial process of evolution of the Earth's surface, do you think that the soil was there? No. During the initial process of evolution of the Earth, it was a barren land. Okay, the Earth was a barren land. It was only rock, especially the igneous rock. Okay, during its initial process of formation, the Earth was in a molten state. It was very volatile and it was very rocky and very barren. By the process of weathering and erosion on the barren rock, that is the igneous rock or metamorphic or sedimentary rock, weathering and erosion led to the dislodgement of this rock deposited somewhere, finally resulting in the formation of this soil. That is how a soil came into being. Okay, as a very brief introduction. Okay, now soil links climate and vegetation. Okay, soil, because the vegetation will come out from this soil. Vegetation does not grow from the thin air or from the atmosphere. It requires soil. Depending on different type of soil, different type of vegetation will be there. Another important point is the type of soil. Okay, the type of soil in any location is dependent on the climatic condition of that location. That's why the soil that you will find in the equatorial region will be different from the soil that you will find in the polar region or in the tundra region. Clear? Which means a climate is responsible for the type of soil. Now the soil is also responsible for the type of vegetation. Vegetation and climate is again interrelated. Therefore, that is how soil links the climate and vegetation. They are all interdependent to each other. Clear? Effect on man's activity also. The type of soil determines the type of agriculture in a very simple sense, or type of any other economic activity. The type of soil will determine the type of economic activity also. Okay, also at the same time for the construction of infrastructural construction, so on and so forth. So soil also affect man's activity. Soil is not a passive object. Soil is full of life. Okay, it is the source of water and mineral nutrients for the plants living in it. Also, plant material decay. If I have a soil, if I have a vegetation, this vegetation or the plant, the leaf will fall down, will decay. After decay and decomposition, it becomes humus, and the material, the nutrient which is present here is recycled again. Okay, home to many tiny animals, bacteria and fungi. This soil. Okay, the scientific study of a soil is known as batology or bathogenesis. Now, on any surface of the soil, if you dug out a column of a soil, it is known as a soil profile or a soil horizon, which it will look like this. It is nothing but the soil profile or soil horizon. If you dug out a vertical column of a column of a soil, it is known as soil profile or soil horizon. Till what depth you will take out? As I told you just now, soil is formed from the parent rock. In the initial formation, during the initial evolution or formation of the earth crust, the soil was not there. It was rocky parent, the earth surface. After weathering and erosion, only soil was formed, which means underneath the soil we have a parent rock. So till this parent rock, if you dug out a soil column, it is not a soil profile or soil horizon. That is different layering. Now, if you go to different part of the world and you dug out this particular vertical column of a soil, the depth of this column will vary depending on the location. And that location again is dependent on the where it is located. What is the climatic conditions? What is the vegetations like? Okay, that is how. Let us go ahead. What are some of the important characteristics of this soil? As I told you just now, we have seen soil is not passive, but it is very active and it is full of life. Okay, how it is? The soil consists of solid, liquid and gases. In a sense, if I have a soil, okay, now it is not only the solid particles that combines together to form a soil, but between these tiny grains of particles which combines to form a soil, there is a pore space. The space is there, the pore space is there. In this pore space, I have gases like oxygen. Also, at the same time, I also have water. Whenever there is a precipitation or whenever any water flows through this, it is percolated down and accumulate in between this pore space. Therefore, if I consider a soil as a whole, it is not only the solid object, but also you have liquid and gases. Now, all of this liquid and gases in the soil is responsible for determining the characteristics of this soil. The characteristics of this soil will further determine the type of vegetations, okay, that it can support. Okay, and also see, soil, if the gases are not there, if the soil is not well oxygenated compared to another type of soil which is well oxygenated, the characteristics will change. Okay, now the soil also consists of organic matter, that is living and decayed plants and animal, roots and worms. That is the end product of a humus. What is humus? When, if this is a soil, I have a vegetation, the leaf will fall down, it will decompose and decay, finally turning into a humus. Okay, now all these are organic matter. Why? Because it is a decay of plant. Also, it may be a decay of the animal also. They all combine together to form this organic matter. After decay and decomposition, this organic matter also become part and parcel of the soil. Therefore, the soil consists of organic matter also. At the same time, In soil, I have inorganic particle also, or matter. What is inorganic? As I told you just now, the formation of the soil respond the parent rock contribution. After all, the soil is formed by the weathering and decomposition, okay, of the parent rock. So from the parent rock, inorganic material is also supplied in the formation of the soil. Clear? So the important characteristics of a soil is it consists of organic as well as inorganic material. From where the organic and inorganic material comes, I have just explained to you. And at the same time, soil exists in solid, liquid and gaseous form. And that is how a soil connects lithosphere, hydrosphere and atmosphere. Clear? I'm very sorry. One important characteristics of soil is soil texture. Okay, soil texture. Soil texture is, you see here. Suppose if you go to a market. Harish, good afternoon, good evening and welcome to the session. You see here, if you go to a market to buy a cloth, if you go and just touch the cloth like this, okay, just touch the cloth like this, the feeling that you have, if it is a silk, you feel different. If it is a cotton, you feel different. That is the texture of that particular cloth. Similarly, when it comes to a soil, soil has got different texture. Okay. Now, the texture of a soil is determined by the size of the solid particle composing the soil. Okay. As I told you just now, a soil composed of tiny particles combine together to form a soil. So, what is this tiny particle? They are broadly of three types. It may be clay, it may be silt, it may be sand. Okay, so broadly, the soil is a combination of sand particle, clay particle or silt particle. Now, the ratio with which this sand, clay and silt are combined together to form a soil, depending on that, the soil texture is determined. A soil texture is determined from gravel to clay. Therefore, you see here, this is one particular triangle that is used in order to determine the texture of a soil. You see here, at this particular vertex or peak, it is the fully clay. It is fully clay, 100% clay here. At this particular end, kindly follow the pointer. At this particular end, it is fully sand. It will be a fully sand. At this particular peak or point, it is fully silt. Okay. Therefore, suppose if I have a soil of this nature, then it is 100% sand. If I have a soil in this category, it is fully silt. If I have a soil in this category, it is fully clay soil. If I have in equal proportion clay, sand and silt in equal ratio, it can be a loamy type of soil. Clear? Now, say for example, just for your example, say for example, if I have a soil in this category, which means like around 40 to 50% of sand and clay, it can be a sandy clay soil. Similarly, if I have a proportion, the ratio of combination is thus such that 50 or 40% of silt and 40 and 50% of clay, it can be a silty clay. That will be the texture of that soil. Clear? And the texture is nothing but the size of the soil particle composing the soil. Clear? It is not as the texture. I hope that is clear. Now, texture determines the water retention properties of a soil. That is another very important application. Why texture is important? Because texture determines the water retention properties of a soil. Means, say for example, if I have a soil, if there is a precipitation or a water is supplied to it, whether this particular soil will retain this water or will allow this water to percolate down or will not allow this water to percolate down and resulting in the runoff, it all of this is determined by the soil texture. It is important. Why? Because depending on the water retention capacity or the characteristics of this soil, the type of the soil, whether it is fertile, not fertile, whether it is fit for cultivation, whether it is not fit for cultivation, will be determined. Therefore, the texture plays a very, very important role. I hope this is clear. Just to give you a rough idea about the size of different particles that is composed to form a soil, that is the silt, clay and sand. You don't have to remember this numerical figure, but just to give you an idea about the size. The clay is the smallest particle in the soil. Okay, clay is the smallest particle in the soil. The size is up to 0.002 mm. It is known as clay. A particle of the size which is up to 0.002 mm. It is known as clay. So clay is the smallest particle that combines together to form soil. The second comes the silt. The size of the silt is from 0.002 to 0.02. That is the size of a silt. The size of sand is, fine sand is 0.02 to 0.2. Okay. Tracy, Shan, good evening and welcome to the session. The sand, if it is a coarse, you see here, the sand has two sides. One is the fine sand, other is the coarse sand. The coarse sand size varies from 0.2 to 2 mm. The gravel, okay, the general term that we are using, gravel. From now on, you should be very clear. When we talk about gravel, the size is 2 mm and above. It is known as a gravel. Clear? I hope that is clear. Let us quickly go ahead. Soil structure. Soil particles grouped together. Okay. Soil particles, when I talk about soil particle, it is the sand, silt and clay. They are grouped together. The ratio of their grouping determines the texture. What is the size? We have just seen. What is the importance of this texture? Water retention capacity? We have just seen. Soil particles grouped together in a soil when a soil is broken up for tillage. Okay. So, if you just go and till the soil, certain, see for example, you go to any locality. Okay. You can just experiment by yourself. You go out, dig some soil. Okay. Now, any particle, when you dig the soil or when you till the soil will come out. Now, depending on the type of the soil, if you dig the soil, different structure results. Okay, if you take a spade or if you take a shovel, okay, if you dig the soil, it will come out. In what shape it is coming out, that is the structure of the soil, I can say. Clear? It is the structure of the soil. Depending on the nature of the soil, different structure will come out. Different shape of the soil will come out. The soil particles group together called flocculation. The term is important. This is done by tiny clay particles. The binding of the soil particle is done by clay, an organic particle known as colloidal substance in the presence of water. This in detail we will discuss later. But the important part is the soil structure is, the basic type of soil structure is granular. if you dig the soil, if you till the soil, if the soil come out in a small particle in a granular shape, it is known as granular structure of the soil. If the soil come out when you till it in a block manner like this, it is known as blocky soil. If it comes out in this manner, it is perismatic. If it comes out in this manner, it is a platy, layer after layer. This is the structure. And this is the massive. If huge block comes out, it is the massive. These are the different basic type of soil structure. Clear? The unit of a soil structure is known as PETS. P-E-T-S. Soil structure determines permeability and porosity. You see here, the soil texture which we have seen just now determine the water retention capacity of a soil. Similarly, the soil structure will determine the permeability and porosity of a soil. Soil structure is also determined by organic matter derived from the plant decomposition. We have seen just now that the soil has organic as well as inorganic. Organic matter is given by the living plants and animals after their decay and decomposition. Okay, so the soil structure is also determined by organic matter derived from the plant decomposition. Example, grassland. In grassland, the soil will be determined by the decay and decomposition of the grass after it dies down, become humus. After some time, it will become a part and parcel of the soil. Therefore, in a grassland, grams-like soil structure you will find like this. Grams. Okay, now it also determines the ease of cultivation, aeration, moisture absorption and erosion. Depending, see, the structure of the soil, the importance of the structure of the soil, you see, it determines the ease of cultivation. Okay, while preparing the soil, while tilling the soil, depending on the structure of the soil, the ease of cultivation will be determined by the structure of the soil. The aeration, we have just seen the soil is very active. It is not a passive entity, and soil consists of solid, liquid and gas. Aeration means circulation of the air, or I can say the oxygenation. Okay, means how well the air circulates in the soil. The aeration is also determined by the soil structure. The moisture absorption, okay, permeability, porosity, and also of the erosion. The erosion of the soil is also determined by the structure of the soil. That is the importance of this soil structure. I hope that is clear till now. If you have any doubt on any portion that we have discussed so far, you can kindly go ahead. Thickness of a soil. As I told you, the soil profile. You dig the vertical, you dug out a column of a soil above the parent rock. That is the soil profile. Okay, I have already mentioned to you, a soil profile is not similar in all the part of the world. Different location will have different soil horizon or soil profile, the thickness. It ranges from few inches in certain places to several feet in other places. The thickness of the soil is also determined by the nature of the bedrock. After all, the soil is formed from the weathering and decomposition of the bedrock. Some rock is hard, some rock is soft. Okay, depending on the, and also remember the climatic conditions also at the same time. Clear? The slope of the land also determines the thickness of a soil. Example, say for example, I have one region, a plain area. I have another region sloping like this. The thickness of the soil will be more in the plain region. In the hilly slope, because of the force of gravity, the weathered material will be flown down. Therefore, in the slope, the thickness of the soil will be less as compared to the plain area. So the slope of the land also determines the thickness of the soil. The speed of mechanical and chemical weathering. I have underlying parent rock. Okay, parent rock. Same parent rock, say for example, let me represent by R1 type of rock. If this is in one climatic condition, same type of rock R1 in another climatic location. Now, the climatic condition determines, the climatic condition determines the speed of weathering. Chemical or mechanical weathering is determined by the climatic conditions. Say for example, limestone. Let me give you just one example, limestone. Limestone. If the limestone is there in the equatorial or tropical region where you have sufficient moisture and temperature, the weathering will be very fast. But if this same limestone, if it is there in arid and semi-arid region where the moisture or where the water is less, because in arid and semi-arid region the water availability is very less, this particular limestone, which is very vulnerable or which is weathered very fast in the tropical and equatorial region, will act as a very resistant rock in the arid and semi-arid region, which means depending on the climatic conditions, the speed and the nature of the chemical and mechanical weathering will vary. Therefore, the thickness of the soil is also determined by the speed of mechanical and chemical weathering. And next is the overlying vegetation. In a place where you have sufficient vegetation, the thickness of the soil will be more. Why? Because the soil consists of organic and inorganic material. The organic material is supplied by the vegetation. Clear? Therefore, these are the important factors that determines the thickness of a soil. I hope that is clear. Let us see one of the most important characteristics of a soil. You see here, the transfer of nutrients, the transfer of bases, let me tell you, is not so simple as you think in the soil. How it is transferred? Let us examine a little bit in detail. The transfer of nutrient or bases in the soil is done by soil colloids. Soil colloids. Now, what is this soil colloid? Soil colloids are the tiny particles with unusual chemical properties. Soil colloids. Now, soil colloid is nothing but it can be either organic in nature or minerals. Organic supplied from the finely divided humus from the vegetations, or it can be a minerals, that is the clay minerals. Combined together to form this clay humus complex, which is nothing but the soil colloids. That is the tiny particles included in a clay fraction of the soil with unusual chemical properties known as soil colloid. So what is soil colloid? Soil colloid is, you can say it can be either a clay minerals or it can be a organic material, that is finely divided humus, or it can be a combination of both called as a clay humus complex. Now, the unusual chemical properties that is given to the soil colloid is given by these clay minerals. How? The clay minerals, it has a vast surface area in relation to the weight. The clay minerals, in relation to the weight of these clay minerals, the surface area is quite large. And also, these soil colloids, they are negatively in charge. They are negative in charge. The soil colloids, they are negatively in charge. The charge of the soil colloid is negative. And what is soil colloid? It can be either a clay mineral, or it can be a finely divided humus, that is the organic content, or it can be a clay humus complex. Now, this soil colloid has a negatively charge. Therefore, when it is negatively charged, it will attract the positively charged ions such as sodium, Na, cations of sodium. Sodium is plus charge, potassium, that is plus, calcium, that is a positively charged, magnesium, that is positively charged in the ionic form. I am talking about the ionic form. Okay, the positively charged ions of sodium, potassium, calcium, magnesium, they are known as the bases. We call it as a base. Now, since soil colloids are negatively in charge, it will attract the positively charged bases, that is sodium, potassium, calcium and magnesium and others. Okay, from where this bases will come? The bases will come from the n number of source, artificial or natural. Natural, artificial can be the fertilizers. Natural can be the vegetations or XYZ source. Okay, now after the decay of organic matter, it will turn into humus, supply of these bases in the soil. Now, a plant require, okay, if I have a plant here, it is soil, the plant will have a roots. The basis or in the plant is taken up from the root. Okay, from the root of the tree. The required basis for any vegetation, be it plant or any other agricultural crop, it is observed by that vegetation from the root. Therefore, the basis which is available on the soil surface needs to be transported below, so that the root system will be able to observe it. Now, the transportation of the bases from the ground surface below is done by this soil colloid. Why? Because the soil colloid is negatively in charge. It will attract the positive ions of the bases. It will carry below. Once it is carried below, okay, below I have these hydrogen ions in the soil. Hydrogen is also a positively charged ions. These hydrogen ions have a greater affinity towards this soil colloid as compared to other bases. Therefore, this hydrogen ion will replace these bases. So, this basis which is carried by the soil colloid from the surface below is precipitated out, or it is given out, and it is replaced by the positive hydrogen ion. Now, these bases are transported from the surface below. It is available, so the vegetation or the plant root will take up these bases. That is how. Now, when by the process of this replacement, hydrogen ion is acidic in nature. So whenever you have more of this hydrogen ion getting replaced, the soil will become acidic. So in order to replenish, okay, if a soil becomes too acidic, it can be disrupted by providing fertilizers. That is how. Okay, that is the entire process and the mechanism and the importance of this soil colloid. Therefore, at the outset, I have already mentioned to you that transfer of bases is not simply by the percolation of the water from the surface to the inside of the soil. Okay, from the surface, it is not by the percolation of the water, but it is by the soil colloid, which is transferring the bases from the surface below, giving out, making available for the vegetation to take up via the roots. That is the basic function of this soil colloid, which is one of the main and very important function that is performed in the soil ecosystem. Clear? Anyway, we'll end the session here today. Tomorrow we will continue with this soil color. Okay. And after finishing the important characteristics and the formation of the soil, we will begin with the classification of the soil. Thank you so much for your patience and cooperations. Tomorrow also we will conduct at the same time 9 to 9:40. The session is composed of 40 minutes. Okay, so we will continue tomorrow at the same time. If you have any doubt on any point that we have discussed today, you can always revert back to me tomorrow. Okay, thank you so much. Bye bye and